everybody, welcome to the NMR workshop. This is the online answer for this NMR. This is question 1. Okay, if we check in question 1, what we have is an NMR. That is the NMR of a mixture of two products that I draw here. In black, the trans double bond, and in red, the cis double bond. Okay? These are from a basic product, and then the question is determine the ratio of alkenes and which alkene is the major product isomer. Okay? How we can do it? Basically, the first thing is to know what knowledge of NMR we can apply in order to do this exercise. The first one is that we know that for a compound, for example this compound, the integration of each NMR proton will be proportional to the number of hydrogens. Okay? For example, here HA will be integration 1, HB will be integration 1 because both are one proton, while HC, the integration will be 2 because we have 2 HC. These two protons are equivalent by symmetry. Okay? And exactly the same for this compound. HA will be integration 1, HB will be integration 1, HC will be integration 2 because they are symmetrical. Okay, that means that we know that the NMR of this compound in the region where are HC, HA and HB will be 1, 1, 2. Exactly the same than for the red one. The region where are HC, HA and HB will be 1, 1, 2 integration. Okay? Second thing that we know. This free proton, HA, HB, HC, will be in the area, or in the region, between 5.5 and 7. That is the region that I reproduce in the whiteboard. Okay, this is a copy, not so good, but it's a copy of the NMR that you have in your exercise. Okay, we have a doublet around 7 that integrates 1, a singlet a little bit less than 7 that integrates 0.8, 6.5, a 6.5 we have a singlet that integrates 2 more or less, at 6 we have a doublet, not nice doublet, but a doublet that the integration is 0.4, a slightly down of 6 we have a doublet that integrates 1, and at 5.5 more or less we have a doublet that integrates 0.4. Okay? And if we analyze these molecules, we know that HA will be a doublet because it's coupling with HB, okay, a J free. Okay, HB will be a doublet too because it's coupling with HA, and HC will be a singlet because it's not coupling with anyone. We don't have any hydrogen close. And for the other product, for the cis product, is exactly the same. HA will be a doublet that couples with HB, and HC will be a singlet, HB will be a doublet that couples with HA. Okay, then, with all this information, what we can do is to try to check which signals are from one compound and which signals are from the other compound. Okay, if we take, for example, this doublet, this integrates 1, okay, a doublet that integrates 1, what we need to see is in any of two compounds, I am not identifying this signal with any of these compounds. I only want to find the set of signals that are together, that are from the same molecule. If we have a doublet that integrates 1, we need a singlet that integrates 1. That will be the singlet at 6.5. Okay, and then we need a doublet that integrates 1. Okay? Good. This will be one of the products, which we don't know, but will be one of the products. We can join the other signals, yes. Here we have a singlet that integrates 0.8. I will put it with, I can choose another color. We have this compound that is 0.8. If we have a singlet that is 0.8, we need a doublet that integrates half of this, 0.4, in order to have a relative integration of 1 to 2. That means we need a doublet at 0.4 and another doublet at 0.4. That means this, and this signal will be together, will be the same compound. This, and this will be the other compound. Okay? Now, how we can identify this set of signals, the red set of signals and the green set of signals with each of these compounds? Well, we have to analyze the structure of the compound. The main difference between this compound and this compound is the double bond. Okay, we have here a trans double bond, and here we have a cis double bond. And then what we can do is to go to the Karplus diagram. We know that in a trans compound, the coupling between HA and HB will be the coupling of 180 degrees. Okay? While here, the coupling between HA and HB will be 0 degrees. Okay? With this information, we can go to the Karplus diagram. And what the Karplus diagram is telling us is that the coupling, this is how height will be the coupling constant, how big will be the coupling constant. Okay, at 0 degrees, okay, here we have, will be lower than at 180 degrees. That means if we do this, this will be between 7 and 11, more or less, and this will be between, for example, 11 and 18. Okay. That means clearly we will have a difference in the coupling constant. That means if we analyze the coupling constant of this substrate, we can know which is the nature of the double bond, if cis or trans. For example, we can use this signal, this doublet. If we check the NMR, we have that the difference is 2000. Okay, this is the first peak, and this is the second peak. That means that the J coupling will be the suppression of one peak to the other, and will have around 12.8 Hz, if I take the right numbers. And for example, we can take the coupling constant of this signal. Why I take this signal? Because we know that it's a doublet. That means that has to be HA or HB. We don't enter which will be. We can know it basically by the electronic structure around, but it's not important. We know that this compound, this signal, will be HA or HB in some of these compounds, in one of these compounds, okay? And the coupling constant has to be the same in this signal that in this signal. That means that I only need to take one in order to define the coupling constant. Okay, remember that the coupling constant between a proton A with proton B is exactly the same that the coupling constant between the proton B and proton A. Okay? If I take this signal, if I take, well, the numbers is 1838 and 1830.7. That means that if I do the rest, it's 7.3 Hz. Okay? The only that I did is calculate the coupling constant of the signal that corresponds to HA-HV of any of these compounds, and this signal that corresponds to HA-HV of any of these compounds. Could be anyone. That means that now I relate these results with the Karplus diagram. I got a bigger J coupling that, if I check the Karplus diagram, will correspond to 180 degrees. That means that this signal, the red signal, corresponds to the J coupling of 180, that is exactly the coupling of a Kranz compound. While the green one will correspond to the cis, because the coupling is lower, is smaller, is 7.3 Hz. Okay, this is how we identified each set of signals with his structure. The green is the cis, the red is the Kranz. Okay? Now, how we can determine the relative concentration of each of the alkenes? Well, we know that the concentration is proportional, the concentration of a compound is proportional to the integration. That means, for example, for HA and HA of each compound, the integration will be proportional to the concentration of this compound. That means the signal integration of signal A divided, integration of signal A divided by the integration of signal A will be equal at the concentration of the compound Kranz divided by the concentration of compound cis. Okay? That means that if we use this, for example, we will use the same signals that we use for the coupling constant, this signal and this signal. The concentration, the integration of the compound Kranz will be 1 divided by the cis is 0.4 will be equal to the concentration of Kranz divided by the concentration of cis. Okay? That means that if we do the calculation, we will have that Kranz, the concentration of Kranz is equal to 2.5 the concentration of cis. Okay, that means that we have 2.5 of this compound to 1 of the Kranz to the cis. Okay? Right? That means for each proton, that are the same number of protons in each compound, this signal will be 2.5 bigger than not the signal of HC. And we can see it here. This compound that is a doublet that corresponds to HA or HV, the integration is 1, while the integration of the HA or HV in this compound is 0.4, 2.5 times smaller. Okay? And this is how we do the first question of the NMR. Thanks for your attention, and I will put the other videos of the question 2, 3, and 4. Thank you.